Half a day students, today we're going to be going over the distributive property. I know we've done this before, but we'll do a quick review and then add on to it. So we're going to be going over distribution and simplifying functions using distribution. For the first example, we're doing the same kind of thing we did last week, which is to find the area of a rectangle whose width is 3 and whose length is x plus 2. So the first thing I actually want to do is draw a rectangle and label the length and the width. So its length is x plus 2. Its width is 3. So I usually just make the width be the shorter side. The area of a rectangle is given with the formula area is equal to length times width. Okay, so from there I can plug these in. I can say, okay, my area of this rectangle is going to be x plus 2 times 3. And what I'm going to do is just multiply each of the numbers, each of the terms inside the parentheses by the term that's on the outside. So I'm going to multiply it to each of them. I'm distributing, right? So I'm multiplying 3 times x plus 3 times 2, which is 6. So this expression represents the area of the rectangle. The distributive property is illustrated here. So we have a times a binomial where everything is positive. I'm just distributing it to each of these, right? So it'll be a times b plus b times c. When everything's positive, it's really easy. And it's the same when a occurs after the parentheses. So from there, I'm actually just doing the same thing because we know the commutative property of multiplication, right? Order of multiplication doesn't matter. So it makes sense that I can also multiply it even though it's behind the parentheses. When we have negatives is where it gets to be just a step more complicated. This basically just tells me that, okay, when I multiply, I have AB plus A times negative C, right? So when I'm multiplying, I'm keeping this negative with the C. And when I have a plus, AB is positive, plus A times C, negative C is negative AC, right? And this actually becomes a negative because when you're adding a negative, that's the same as subtracting. When we simplify, we only want to have one symbol in between our terms. Same thing on the bottom here. I'm multiplying to each of these. A times B, A times negative C, simplified to AB minus AC. Looking at example 2, we're actually going to do some more distribution here. 2x plus 2 times 5. I'm multiplying it to each of the ones on the inside and distributing it, right? From there, I'll just simplify. 2 times x is, it's an equal sign. Two times 5 is 10. This next one, x times x plus x times negative 4 now. And I know this x times x is just going to be x squared. X times negative 4 is going to be negative 4x. And again, this was actually plus negative 4x, which I just simplified already. I went straight to simplifying it to be minus 4x. Letter C, I'm actually going to just do the same thing, distribute to both 2x and 1. So I know that 8 times 1 plus, sorry, I'll just put equal signs to all of these. 8 times 2x. Simplifying from there, 8 times 1 is just 8. 8 now times 2x. Whenever you're multiplying something and there's variables and numbers, you're going to multiply the numbers together first. We have 8 times 2, which is 16, positive. And then we just multiply the variables. So our only variable here is x, so it's just going to be an x there. Looking at this one, letter D, distributing to each of these, and I do want to see your rainbows in your work. Y times 1 plus y times negative y. Y times 1, that becomes just y, right? And when I have y times negative y, multiplying the numbers, I can just imagine this is just 1, right? 1 and negative 1. Whenever you have no number, you assume it to be 1, right? If it's negative, it'll be negative 1. So negative 1 times 1 is going to be negative 1. And then we have y times y, which is y squared. A nicer way to write this would be y minus y squared. Now we're actually distributing negative numbers. So when I see this negative 3 times x plus 4, I'm actually going to distribute negative 3. So I'm multiplying each of them by negative 3. And negative 3 times x plus negative 3 times 4. And you'll notice again I have this plus a negative. I'm going to simplify that to be minus, right? So that's going to be minus. Negative 3 times x is just negative 3x. Negative 3 times 4 is going to be negative 12. And I'm simplifying to just be minus. So now we're actually going to be looking at some words that we're going to be using often throughout this year, like terms and coefficient. So in a term that is a product of a number and a variable, so I can think of 3x, right? That's something we see very often. So I have a number and a variable multiplied together to make one term. The number is the coefficient of the variable. So the coefficient of 3x is 3. If I had a number, so if I had a polynomial with two terms, a binomial, x squared minus 5x, right? The coefficient of x squared, I have two terms here, the coefficient of x squared, if there's no number in front of your variable, it's understood that the coefficient is 1, right? The coefficient of negative 5x, you're actually going to account for that negative and keep that with the number. So my coefficient is actually negative 5. Like terms are terms that have the same variable raised to the same power. So for example, if you have 4x and negative 10x, these are both like terms. If you had negative x squared and 3x squared, those are like terms. So when you think of like 2x and 4x squared, these are not like terms. They have to have the same exponent to be like terms. So same variable to the same exponent. So we can say that an expression is simplified if there are no grouping symbols and all like terms have been combined. So we don't have any parentheses or brackets, and all our like terms are combined. We're going to practice simplifying right now. We have 8x and 3x. So these are like terms, right? So you can actually just think of it as 8 apples plus 3 apples. We have the same variable. I'm just adding them together by adding their coefficients. So this is actually equal to 8 plus 3 times x, which is just 11x. And again, this is actually distribution, right? But kind of going backwards, but a lot of times we actually in math use distribution without even thinking that we're doing that. And this is one example of that. Okay, let's look at letter B now. 4x squared plus 2 minus x squared. If I look at this, I want to see if I have any like terms, right? So simplifying, I don't have any parentheses, but I do have like terms. 4x squared and negative x squared. Make sure to be careful about that negative. So I'm going to combine 4x squared, negative x squared, plus 2. Combining these, I'm left with 4 plus negative 1. That'll just be 3x squared. And then leave that plus 2 there. This last one here, there's something different. I don't see any like terms, right, really. But what I do see are grouping symbols. In order to get rid of these grouping symbols, I'll actually distribute that negative 2 first and then simplify from there. So when I distribute this negative 2, so I have this 3 on the side. I have negative 2 times 4 You can either put plus negative 2 times x, or you can just put minus 2 times x. We're left with 3 minus 8 minus 2x. Simplifying, 3 minus 8 is going to be negative 5 minus 2x. And this has no grouping symbols, no like terms. Perfect. So looking at this last example now, it takes you 45 minutes to get to school. You spend t minutes walking to the bus stop and the rest of the time riding the bus. You walk 0.06 miles per minute and the bus travels 0.5 miles per minute. Sorry about the typo there. Okay, the total distance you travel is given by the function d equals 0.06t plus 0.5 times 45 minus t. Simplify this function. So actually, even though I have this long word problem with a lot of information, I don't even need to make any functions, anything like that. All I have to do is simplify the function. I'm not actually solving for anything. So what I'm going to do is I'm going to take this given function and simplify it by combining my like terms and getting rid of parentheses. So we have d is equal to 0.06t. A good thing to do is always just rewrite it, plus 0.5 times 45 minus t. Okay, and this is a distance formula. Okay, so what I'm going to do first is distribute this 0.5. And whenever you're distributing 0.5, you're just taking half of everything in the inside. Or I can just say, okay, 0.06t plus 0.5 times 45. Half of 45 is half of 40 plus half of 5. So I have 22.5 minus 0.5t. From there, I'll combine like terms. I have a t and another t, right? Both raised to the first power. Combining them, 0.06 minus 0.5. Plus 22.5. That's the end of the lesson. Be sure to do some questions in the book if you feel like you need extra help beyond the assignment. And let me know if you could use some extra tutoring on this, because it's really important. We're using it forever. So otherwise, good luck. I hope you had a good Monday. Goodbye.